Hello and welcome back. This is the third and, at least for now, final part of my Othello tutorial. Here is what we will add in this video. We need this text which displays the current player. It will also be used to show if a player cannot move and if neither player can move. When the game is over, we will show this counting of the discs and, of course, the winning player. There is also a button here which we can press to restart the game. But before we get started on the UI, I want to fix a small issue. Here is our Othello game so far. Last time we added these highlights which show the legal moves, but we detect which square was clicked by performing a raycast against the collider of the board. So we can actually click outside a highlight and the move will still be performed. This can be a little confusing if the user accidentally clicks somewhere between two squares. What's worse is that we can even click down here because the ray will hit the side of the board's collider. This could be fixed simply by reducing the depth of the collider so it only covers the top. But a better option that solves both issues is to raycast against the highlights instead of the board. Let's make this change. First, we remove the box collider from the board. Now the only objects with colliders are the highlights. Next, we open the UIManager script. Here we have this layer mask for the board layer, which we don't need anymore. We could create a new layer for the highlights and then raycast against that, but instead, let's just take advantage of the fact that only highlights have colliders now. So, in update, we can now use a simpler overload of physics.raycast. If we hit anything, it is for sure a highlight. It cannot be anything else. That's it really. Everything should work as expected now. But this change comes with another advantage. The highlights for a turn are only visible after the previous move is finished. So we can actually just get rid of the can move boolean. And everything related to it. Great. We have cleaned up the code a bit and it is now only possible to make a move by clicking on a highlight. With that out of the way, let's start working on the UI. We need a UI canvas. The render mode should be set to screen space overlay and we want the UI to scale with screen size. Our reference resolution is 1920 by 1080 and I want the canvas to scale with the height as reference. Let's change the layout of the editor a bit so we can see the scene view and the game view at the same time. Alright, we need some text and it should be Text Mesh Pro. To import it, we just have to click this button here. This text will display the current player and also when a player's turn is skipped. It will be located at the top of the screen, so I will call it top text. We will position it relative to the top of the canvas with a Y position of -65. The text is quite small, so let's set the font size to 60. And in the spacing options, set character spacing to 10. We will also center and middle align it. To make the entire text fit on one line, we can just disable wrapping. Under the shader settings, go to face and set dilate to 0.35 And finally, let's give it a black outline with a thickness of 0.2. You are of course welcome to change these settings if you want a different look, but this is what I will be using. Right now, the text just says new text. It doesn't really matter because we will control it from code, but I will change it to top text. Let's hide this text for now, because the rest of the UI elements are for the end screen. When the game is over, we start by counting the disks. For that, we need two text elements. One for the number of black disks and one for the number of white disks. I want to use the same component values that we used for the top text, so we can just copy and paste them. The only thing I will change is the actual text string. We will position these text elements relative to the center of the canvas at y equals 475. The black score text will be at x equals minus 150 and the white score text at x equals plus 150. Once the disks are counted, the screen should fade to black. To achieve that, we add a UI image. I call it black overlay. To make it span the entire canvas, click here, hold down Alt, and then choose the bottom right preset. Obviously, it shouldn't be white, so I will set the color to black with 80% opacity. It is currently rendered on top of the black and white score text, so we must move it up in the hierarchy. We need one more text element which will display the winner. I will set its Y position to 125 and paste the component values we copied from the top text. There are only two values I will change: the text string and the font size, which I will set to 90. The final UI element we need is a button for restarting the game. We need this UI button, which uses Text Mesh Pro. The button's Y position should be minus 125. I want the width to be 450 and the height to be 100. I will also change the button's normal color to bright green. The text looks pretty bad, so once again, we paste the component values we copied before, change the text to play again, and set the font size to 54. That's actually all the UI elements we need. But what about these disk sprites? How will we display those? Using Text Mesh Pro, we can actually display sprites in line with text, which is awesome. We must set the texture type to Sprite, 2D and UI, and the sprite mode to multiple. Click Apply, and then go to the sprite editor. If you get a message like this one, just go to Window and open the Package Manager. From here, choose Packages, Unity Registry, and then you should see a 2D Sprite tab. Select it and click the Install button. Now it should be possible to open the sprite editor. We want to slice these sprites, so click up here, and for the type, choose Grid by Cell Count. Set columns to 2 and rows to 1, then hit Slice. Now we have two separate sprite assets. Click on the left one and call it Disk White Up. Similarly, we will call the sprite on the right Disk Black Up. Now click Apply and close the sprite editor. As you can see here, there is now a separate sprite for each disk. To show them in text, we have to create a Text Mesh Pro sprite asset. Let's try it out on the black score text first. Under extra settings, we have to tell it to use our sprite asset. So just drag and drop it here. Now we can show our sprites in line with the text using tags. Here is how we can show the disk black up sprite. When the game is over and we start the counting, we have seen 0 black disks. So after the sprite, let's add a 0. Cool. But the sprite is not aligned very well with the text. To fix that, we need to change some settings for the sprite asset. We can make the sprite a bit bigger by clicking on Sprite Glyph Table and setting the scale to 1.5 for the black disk. To fix the alignment, we will set BX to 0 and BY to 380. We will use the exact same values for the white disk as well. For white score text, we also apply the sprite asset. And this time we show disk white up. Okay, when the game starts, only top text should be visible. So let's hide these UI elements and show the top text again. Here we also have to assign our sprite asset. This way we can show the sprite for the current player. Perfect. To improve the feel of the game, we will use a few simple animations for these UI elements. You could use the animator component for this, but that might be a bit overkill for what we need. Instead, we will use a free tweening library called LeanTween. Before we can use it, we must add it to our project. To do that, go to LeanTween's page on the Unity Asset Store. You can find a link in the description of this video. Because I have used it in the past, this button here says Open in Unity. If you haven't used it before, it should say Add to my assets. Click on that button and follow the instructions. Once it has been added, click Open in Unity. You should see that the package manager has been opened with LeanTween selected. Click the download button and then import. We don't need the examples, so just untick those and click import again. Super. Now we have everything we need to make the UI come alive. I don't want to cram too much code into the game manager script, so let's create a script called UIManager. This script will be the only one that interacts directly with the UI elements in the scene. It will expose some methods we can call from our game manager. You will see how it works in a minute. For our text elements, we have used TextMesh Pro, so we must import TMPro. And we also need the Unity Engine.UI namespace. Let's add references to the UI elements in the scene. We need a reference to top text, black score text, white score text, and winner text. We also need a reference to the black overlay image, and the play again button's rect transform. We don't need start and update, so they can just be deleted. Alright, let's implement one feature at a time. We will start by displaying the current player in the top text. To do that, we need a public method called setPlayerText, which takes the current player as parameter. if the player is black. Then we set the top text to black's turn, followed by the disk black up sprite. Otherwise, if the player is white, the text should be white's turn, followed by the disk white up sprite. Okay, let's navigate to the Game Manager script. It will only interact with the UI through the UIManager, so we don't need references to all the UI elements. We just need one reference to the UIManager. When the game starts, we have to show which player moves first. So in start, we will call UIManager.setPlayerText with the initial player as argument. And in onMoveMade, we will also call it after the move has been shown. Let's see if it works. Back in the Unity editor, we will add a UIManager object to the scene and attach our script to it. Now we can drag and drop the required references. We also have to remember that the Game Manager needs a reference to the UIManager. Okay, let's try it out. So far, so good. What happens when we make a move? The text updates. Perfect. Sometimes a player cannot place a disk anywhere. For example, after white places a disk here, then black won't be able to move. You can see that the top text still displays white's turn, which is correct. But I think we should make it more obvious when a player's turn is skipped. Back in the UIManager, we will add another public method called setSkippedText. If black's turn will be skipped, we set the top text to black cannot move, followed by the black sprite. And similarly, if white's turn will be skipped. To draw extra attention to the text, we will also add a coroutine which animates it for a few seconds. I will call it Animate Top Text. The idea is to smoothly scale the top text up and down a few times. This is super easy to do using the LeanTween library. We just have to grab the top text transform and call the lean scale method. It takes two parameters, a vector3, which is the final scale, and a float, which is the duration of the animation. I will use vector3.1 times 1.2 for the scale and 0.25 seconds for the duration. This will increase the scale by 20% in a quarter of a second. We also want to scale it back down and repeat this pattern a few times. Here is the really cool part. To do that, we can simply use setLoopPingPong. It will play the opposite animation, so in this case scale back down to 1 and then repeat the whole thing 4 times. After that, we wait for 2 seconds, which is how long the entire animation takes. To check if that works, head back to the Game Manager Here we will create a new coroutine called ShowTurnSkipped. It calls the UIManager's setSkippedText method and then starts the animation we made and waits for it to finish. When a move has been made, there are actually a few different things that can happen. So I want to create another coroutine called ShowTurnOutcome. It takes a moveInfo object as parameter, and it will show the user what happened after that move. There are a few different things that can happen. If the game is now over, then we need to show that somehow. We will take care of that in a minute. Once that is done, we can just end the coroutine using yield break. If the game is not over, we must check if a player's turn was skipped. We start by creating a local variable for the current player. That is, the player who will move next. If the current player is the same player that just made a move, then the other player's turn was skipped. In this case, we call ShowTurnSkipped. The skipped player is the current player's opponent. Finally, we show the current player. In onMoveMade, we will call ShowTurnOutcome instead of the call to set player text. Let's check it out. After a normal turn, the top text is updated just like before. But if a player cannot move, we can see that clearly. When the animation is over, the top text correctly displays which player's turn it is. Now we just have to implement this end screen where the discs are counted and the winner is displayed. There are quite a few things going on here, so let's break it down. First, the top text changes to neither player can move, and it is scaled up and down using the animation we already have. Then the text shrinks and disappears completely. After that, the black score text and white score text are shown. Note that they don't just appear. There is a small animation that scales them up from 0. When a disk is twitched, the black or white score text is updated depending on the color of the disk. Here you can see all those steps combined. Let's implement these steps before we look at the rest. Here in the UIManager, we will add a few helper methods for the steps we need. The first thing that should happen is that the top text is set to neither player can move. So let's create a simple method that displays a given message in the top text. All it does is set the top text equal to the given text string. After the text has been changed, it should be scaled up and down, which we can already do using AnimateTopText. Next, the text should shrink and disappear. For that, we will add a little coroutine called ScaleDown. It takes a rect transform as parameter, so we can use it not only for text, but for other UI elements as well. We start by scaling the UI element down to 0 using LeanTween. The animation takes 0.2 seconds and we will wait for it to finish. Finally, we make the UI element inactive. We also need the opposite coroutine, which scales a UI element up from 0. First, we make sure that the UI element is active and set its scale to 0. Then we use LeanTween to scale it up. The final scale will be 1 and the animation takes 0.2 seconds. Just like before, we wait for the animation to finish. At this point, we can write a coroutine called showScoreText. It hides the top text by scaling it down. Then shows the black score text using scale up. And same thing for the white score text. We will call showScoreText from the UIManager script. Here we will add a coroutine called showGameOver, which takes the winning player as parameter. It displays neither player can move in the top text, and calls animate top text. When the animation is done, it calls showScoreText. Remember that this hides the top text and then shows the black and white score text. In ShowTurnOutcome, we can now replace this comment with a call to showGameOver, passing the winner as argument. Let me show you what we have so far. Okay, we are making some really good progress here. The next thing that should happen is that the disks are counted. In the UIManager script, we need two simple methods. The first one is setBlackScoreText. All it does is update black score text, so it displays the black disk sprite followed by the number passed into the method. We also need set white score text, which works the same way. In the UIManager, we can now implement the disk counting. Here we need variables for the number of black and white disks we have seen so far. Initially, they are both set to 0. For each occupied position in the game state, we get the color of the disk at that position. If it's black, we increment the black variable and update black score text. Otherwise, we increment white and update white score text. Regardless of the color, we also twitch the disk at this position. And wait for 0.05 seconds before moving on to the next disk. In Show Game Over, I will add a small delay of half a second here. And then show the counting. Let's check it out. There is actually a big bug here. Did you catch it? Some of the disks changed color when they were twitched. Let me show you one more time. What is going on here? Actually, the problem has nothing to do with our code. It is the disk animator that is doing strange things. The twitch disk animation does not animate the rotation of the disks, only the position. When a transition to the twitch disk state happens, it will actually reset the rotation to its default value. So if a disk was initially placed black side up, it will also be black side up when it is twitched. Similarly, a disk that was placed white side up will be white when twitched. This is of course really bad because disks are flipped all the time. We can turn off this behavior by unchecking write defaults here. Now everything seems to work as expected. The next steps are to show the black overlay, move the scores down, display the winner, and show the play again button. Combined, these steps look like this. We start by adding a coroutine to the UIManager. Its purpose is to show the black overlay using a fade animation. We make sure that the overlay is active and completely transparent at first. Then we use LeanTween to increase the opacity to 80% in 1 second. And wait for it to finish. Let's also add a height overlay coroutine, which we will need soon. Using LeanTween, we reduce the opacity to 0 in 1 second. Wait for the animation to finish. And then make the overlay inactive. The next step is to move both black score text and white score text down so they are vertically centered. Both score texts are positioned relative to the center of the canvas, so we must move them down to y equals 0. And as always, we will wait for the animations to finish. When the scores are moved down, it is time to show the winner text. But we need a way to set it first. We set the text based on the winning player, of course. If it's black, the text should be black 1. If it's white, then white 1. And if it's player.none, we have a tie. Perfect. Let's connect some of these steps in a coroutine called showEndScreen. It shows the black overlay, moves the scores down, and using scale up, it shows the winner text, and the play again button. Now we just have to invoke it from the game manager. In show game over, after the counting, we first set the winner text, and then show the end screen. Here is the result of our work. There is only one last thing we have to take care of. If I click this button, then nothing happens. So let's fix that. Back in the UIManager, we need a coroutine called hideEndScreen. Using scale down, it hides winner text, black score text, white score text, and the play again button. Note that I have used start coroutine here, so all the animations are started at the same time. We don't wait for one to finish before starting the next. Once all the animations are started, we wait for half a second, and then hide the black overlay. In Game Manager, we need one final coroutine that restarts the game. It calls hideEndScreen, and when that is done, it will simply reload the scene. To do that, we will import UnityEngine.SceneManagement. Now we can reload the scene. We want this coroutine to be called when the play again button is clicked. For that, we need one final method, and I promise it's the last one. All it does is start the restart game coroutine. In the Unity editor, we need to select the button, scroll down to onClick, and press this little plus sign. The method we want to call is on the Game Manager object, so just drag and drop it like this. And then select On Play Again Clicked. After the discs are counted, we see the end screen, and if I click here, the game restarts. That's it. We now have a finished Othello game. Thank you so much for watching. If you have any questions, don't hesitate to ask in the comment section. I really hope that you have enjoyed these videos. If you have, then consider leaving a like and subscribing to my channel.